Hello and welcome to my Pre-Algebra review series. This video covers Chapter 2, Section 9, titled Solving One-Step Inequalities by Adding or Subtracting. By the end of this video, you will have explored the concept of solving one-step inequalities by adding or subtracting. Presented here are both solving inequalities by subtracting and using addition to solve inequalities. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Objective 1. Solving inequalities by subtracting. Solving an inequality is like solving an equation. You want to get the variable alone on one side of the inequality. You can see from the number line that if you subtract from each side of the inequality, here the inequality of -1 or -1 is less than 2, the resulting inequality, -3 is less than 0, is still true. So let's look at this. At the number line, we started off with the inequality of -1 less than 2. Well, here's the -1 right here. -1 here, and here's the 2. So we're saying that -1 is less than 2, and that's true. Then they say the result, if we take and want to subtract some amount, a given amount from each side, it'll still remain true. So here we'll subtract 2 from each side of this inequality. So they start with the 2, and you subtract 2 from the 2, and you get 0. And if you start with -1 and subtract 2, you get -3. So what we're saying then is that -1 is less than 2 is equal to -3 is less than 0. They both shifted, but the inequality did not change. It's still correct. Example 1, subtracting to solve an inequality. We're going to solve each inequality below here and graph the result. Well, I do this. The solution is here already. We're just going to go through it, and then we'll graph it. So it's n plus 8 is greater than or equal to 19. The first thing you should see is, the equal sign right here, greater than or equal, but the equal part says there's a dot involved here, not a circle. A dot. So we're going to say, so we've rewritten the equation here, and in order to get the n by itself, which is the number one rule, we have to subtract the 8 that's there to make it 0, and we have to subtract that 8 from both sides. So we have n plus 8 minus 8 is greater than or equal to 19 minus 8. We subtracted from 8 from each side. The resulting answer is n is greater than or equal to, there it is again, greater than or equal to 11. So if I pick 11 to be right here, and let's say 12 to be here, and 13 to be here, and 10 to be here, and I say, I'm going to put, for n, it's equal, so I'm going to go right to 11, and I'm going to put a dot right there. And now, when you read this inequality, it says n is greater than 11. You've already taken care of the equal, so it's greater than 11. So all the values that you're going to color a line on here are the n values. So all the n values are greater than 11. So n is 11 and a half, it's 12, it's 13, it's 15, 14, a million, 10 million. It's every number that is greater than 11 or equal to 11 is part of the solution of this inequality. B. -26 is greater than y plus 14. Well, when you look at an inequality, the first thing you should look in your head is say, there's no equal to this inequality, so it's going to be a circle. So -26 greater than y plus 14, we have to get the y by itself. And the y stays right here on the right, and we're going to move that plus 14 out of the way. And to do that, we're going to have to subtract 14 from both sides. So here it is. Subtracting 14 from the left side, -14 plus -26 is greater than y plus 14 minus 14. The plus 14 and the minus 14 cancel each other out, and we're left with y is So we're going to say here, negative 40 is greater than y. Negative 40 is greater than y. So we're going to look down here. We're going to say, well, we're going to put negative. These are negatives, and we're going to say here's negative 40 right here, and here's negative 20. How's that? And here's negative 60. We can make these anything we want them to be. And it's not equal, so it's a circle. It's not equal. There's no equal. So it's the 40 with a circle on it. Circle. And negative 40 is greater than y. So that means that the y values are all to the left. Because negative 40 is greater than anything I'm going to write down with a y. So I have to say everything to the left is a solution. Okay? Okay, example 1, check your understanding. Solve each inequality and graph the solution. So this time, go ahead and stop the video. Try these on your own, and when you come back, we'll work them together. Okay, now that you've done that and you're back, you've got your answers, let's go through them, see how we stack up. Problem A, m plus 3 is greater than 6. Okay, m plus 3 is greater than 6. So what did I say? First thing you do is you look at the inequality itself. What kind of inequality is this? It's greater than, no greater than or equal. So right away you think circle, no dot. It's a circle. And the variable m is not by itself. You have to get it by itself. In order to do that, we're going to remove the plus 3. And to remove a plus 3, you have to use a minus or a negative 3 to get rid of. If you have 3 apples, and in order to get rid of your 3 apples, I have to take 3 away from you. Okay, so m plus 3 minus 3. M plus 3 minus 3 is greater than 6 minus 3. So these 3's here cancel, and we get m is greater than 3. So we'll come down on the graph line. We can put our 3 anywhere we choose. I choose to put it here, put a 4 there, I'll put a 2 here, I'll put a 1 down here, 5 up here. Okay, so we're dealing with greater than 3, so we're not going to include 3. We're going to circle around it, and m is greater than that. So m is everything to the right of that dot, that circle. So that means everything along here on your line is included as a solution. It's included as a solution in this. Okay, so now B, 8 plus t is less than 15. So rewriting this, so again, what do? We look at the inequality, and what does it say? Less than. There's no equal to it. So that means we're dealing with a circle. And we're going to have to get the t by itself. In order to do that, we have to do something to the plus 8 to get rid of it, which was you have to add a negative 8 to it. So we're going to do that. We're going to say negative 8, then plus 8, plus t is less than 15, and we had to add the negative 8 here, and we have to add a negative 8 on this side. So these 8's cancel. That's the whole purpose of doing this. Now the t is by itself, and it's still less than, and what's 15 minus 8? 7. T is less than 7. So I'm going to come down here, I'm going to write my 7 right here, and I'm going to have a 6 right here, and I'm going to have an 8 right here. That's all I need on my graph. It's less than, not equal, so I'm going to put a circle around 7. There's the circle, and t is less than that. So t is everything that's less than 7. Here's 7, so t is everything forever less than. There's the solution. C, minus 3, negative 3 is less than or equal to x plus 7. Well, to solve this, we see that we have an equal sign here now. In the inequality, there's an equal, so that means dot. Case closed, we need a dot. So x is not by itself. There's a plus 7 with it. We have to move that plus 7 out of there. In order to do that, we're going to add a negative 7. So we're going to rewrite this thing. We're going to say negative 7 minus 3 is less than or equal to x plus 7 minus 7. Now the minus 7's cancel each other out. We're left with an x on this side greater than or equal to, and it's negative 7, and negative 3 is negative 10. So I'm going to write right here, I'm going to put negative 10. Here's negative what? Negative 9, negative 8, here's negative 11. Okay, here's negative 12. Gotcha? So negative 10 right there, and it's equal to, less than or equal. So I'm going to put a dot right on the negative 10. There's my dot. And now x, okay, let's say this, negative 10 is less than or equal to x. It's easy to think of it that way. It's less than x. So here's 10. And x is everything that's greater than 10 because 10 is less than x, right? Or equal to x. So that means that everything to the right is part of the solution. Because here, negative 9 is negative 9 less than 10? No. 10 is less than negative 9. Negative 10 is less than negative 9. There's our solution. Okay, example 2, a real world problem. And as I read this, it kind of gives me a chuckle because it's talking about computers, and it says nearly 32 megabytes, MBs here, of memory are available for running your computer. 32 megs. If its basic system requires 12 megs, how much memory is available for other programs? So we write out this equation, this inequality. We'll call it an equation right now. Equation format. In words, we say the memory for the basic system, which we know is 12 megabytes, the memory for the basic system plus the memory for everything else, it must be less than the total, and the total is 32. Okay, because it says nearly 32 megabytes of memory are available. Nearly 32. It doesn't say exactly 32 megabytes. It says nearly 32. So it means it's got to be less than 32. So we're going to let M be the memory available for other programs. The equation, so to speak, the inequality would be written as 12 plus M, the remaining memory that's available, is less than, right here, less than 32. Keeping in mind, it's less than because they said nearly 32, not exactly 32 megabytes. So 12 plus M is less than 32. Here it is. 12 plus M is less than 32. I wrote the equation. Now we have to get the M by itself so that we can come up with a solution. And to do that, we have to move the 12 to the other side of the inequality. In order to do that, you have to add its complement or its opposite. So we're going to say negative 12 plus M is less than 32 minus 12. And when we do that, M ends up being 20 because 32 minus 12 is 20, and the 12s over here canceled out. M is less than 20. So less than 20 megabytes of memory is available for other programs. Example 2, check your understanding. So we want you to do this on your own, but I wrote it all out. So we'll go through it together. So an airline lets you check up to 65 pounds of luggage. That's how much you can check totally. Up to. That means including, up to it. One suitcase weighs 37 pounds. One of your suitcases weighs 37 pounds. How much can the other suitcase weigh? Well, in words, this equation would be the second suitcase, your other suitcase, that weight, plus the 37 pounds of your original suitcase that you know how much weighs, must weigh less than or be equal to 65 pounds. There's our inequality. So we're going to let W equal the weight of the second suitcase. That's this one here, the second suitcase. And we're going to say W plus 37 is less than or equal to 65 pounds. We'll write out the equation, which is W plus 37 is less than or equal to 65. And we have to get the W with the weight of the second suitcase by itself so that we can determine what it is. We can't have any part of the 37-pound other suitcase interfering with it. We can only use the W by itself. So in order to do that, we have to move the 37, the positive 37, by adding a negative 37. We add the negative 37 to each side. We have it right here. W plus minus 37 is less than or equal to 65 minus 37. And when we do that, when we simplify, the 37s with the W disappear. The 65 minus 37 becomes 28. And so W is less than or equal to 28 pounds. So objective 2, using addition to solve inequalities. To solve an inequality involving subtraction, we use addition. So if there's subtraction in the inequality, then you have to add to get rid of it, where we are adding a negative to get rid of the positive numbers in the last slide. And this key concept we see here, addition, property of inequality. You can add the same number to each side of an inequality. We talked about that earlier also. The algebraic point of view, and I'm going to read the algebraic piece first because that gives us the global view of what we're going to see on the arithmetic side here. So if A is greater than B, then A plus C is greater than B plus C. Okay? If A is less than B, then A plus C is less than B plus C. That's kind of just a straightforward thinking. If A is greater than B, if 6 is greater than 5, then 6 plus a number, 4 for instance, is greater than 5 plus 4. And it's true. Arithmetically, 7 greater than 3, so 7 plus 4 is greater than 3 plus 4. How about 2 is less than 5? So 2 plus 6 is less than 5 plus 6. All those are true statements. Example 3, adding to solve an inequality. Solve the inequality. So n minus 15 is less than 3. Well, here's the negative that we're talking about, and we're going to be adding to get rid of that negative 15. So we write the equation, n minus 15 is less than 3. And we're going to add now, add to solve. So we're going to add 15 to both sides. We're adding because there's a negative 15 here. We're trying to get the n by itself. We have a negative 15. We have to add a positive 15. Okay? So now these cancel. Negative 15 and positive 15 cancel, make a 0. And 3 plus the 15, because we added 15 to both sides, part of the adding, but added to both sides, that equals 18. So n is less than 18. So if I go down here in the bottom and I say that this is 18 right here, and if that's 18, then this is 19, and this is 17 right here. And it says it's less than, doesn't say it's equal, so we're going to go to 18, we're going to put a circle around it, and then n is everything that is less than 18. Well, if 18's here, that means n is less than it. So this is n. This is n. This is n. This is n. Everything is n that is to the left. Anything to the left of 18 is a solution to this inequality. Okay, example 3, check your understanding. So as before, this is your job to try these out ahead of time without me. So I will give you time to pause the video, pause it, try to solve these problems, these inequalities, and get back with me when you're done. Hit the button and we'll solve them together, okay? So I'm giving you time to stop it now. And now that you're back, that's good. Let's go ahead and try to solve these. So starting with A, it says m minus 13 is greater than 29. Okay, as I like to say all the time, the first thing you do is you look at your inequality and say, what's it made up of? Well, it's made up of a greater than without the equals, so you know it's a circle. And we're dealing with m with some type of a number with it. It happens to be a negative 13, so we know we have to get the m by itself. In order to get rid of a negative number, you have to add a positive number. So positive 13 gets rid of a negative 13. So we're going to do that. We're going to say m minus 13 plus 13, that's what we're adding, is greater than 29 plus 13. And when we do that, we have the m's cancel, the m gets left by itself, the 13's cancel, and we have greater than, and 29 plus 13, well, the answer to that is what? 29 and 10 is 39, and 3 is 42. So 42, m is 42. And then it's greater than 42. And now we're going to solve it. We're going to put this graph on the chart. And I'm going to say right here, I'm going to say that this is 42, right here, 42. So that's 43 right here. And here's 41 right here. Okay, so since there's a circle, no dot, I'm going to put a circle right there around it. And m is greater than that number, 42. So m is anything that's on the right-hand side out to as far as forever. B, v minus 4 is less than or equal to 7. Going back to the rules. What are the rules? Oh, the inequality has an equal sign in there. It's less than or equal, so we're dealing with a dot. So when we solve it, we're going to dot the line. So v is not by itself. It has a negative 4. So we have to get v by itself, which means we have to get rid of the negative 4. To get rid of a negative anything, you have to add a positive something. And that positive happens to be the opposite of the number you're trying to get rid of, positive 4. So v minus 4 plus 4 is less than or equal to 7 plus 4. Okay? And when we simplify this, the 4's are going to cancel, so the v is equal to, or not equal to, excuse me, is less than or equal to 7 plus 4, which is 11. Now, when we graph that, I'm going to say 11's right here, 12's right here, and 10's right here, and v is less than or equal, so I'm going to put a dot on the 11. So now it gets a dot, solid filled in dot. And v is less than that number. So v is anything that's below the dot. Let's do C. T minus 5 is greater than or equal to 11. Well, again, you look at the inequality sign and you say it has an equals in it, so I know I've got a dot. Say it early. That way you won't forget when you're doing the graph. So you have an equal sign, dot, and you have a negative 5 with the t. The t has to be by itself. And the way to get rid of a negative anything is to add a positive of its same thing, its opposite. So here we go. T minus 5 plus 5, its opposite, is greater than or equal to 11 plus 5. Okay? So now, you know, the t gets left by itself because the 5's are canceled, because we intended that to happen, and it's greater than or equal to 11 plus 5, and 11 plus 5 is 16. So there's the solution, and we have an equal sign, so I'm going to write a 16 right here, I'm going to do a 17 right here, and I'm going to do a 15 right here, and it's equal to, so I'm going to put a dot right here on the 16. There's my dot, all filled in, and t is greater than that 16. So that means t is everything that's greater than the 16. Okay? Good.